Hello students, today's topic is finding square root by prime factorization method, exercise 6.3, chapter number 6, square and square roots, class 8. So let's start. Here it is the problem number 4. Find the square roots of the following numbers by the prime factorization method. Fourth problem is given 4096. We have to find the prime factorization for this number 4096. So as we know, if a number contains unit digit is even, so it should be divided by 2. So we will divide this 4096 by the prime number 2, and the prime numbers are the numbers which has no common factor other than 1 and the number itself. So let's divide it by 2. So we get, after division, 2048. When 4096 divided by 2, we get quotient is 2048. Again this 2048 divisible by 2, so again we divide it by 2, so we get 1024. Now 2 ones are 2, 2 zeros are 0, 2 twos are 4, and 2 fours are 8. Then again this number is even number, so we will divide this by 2, so we get 512. Again 512 has the unit place 2, so we'll divide it by 2 again, and we'll get 256. Again it is a even number, so we will divide this by 2, so we get the number is 128. As it is 128 is even number, it should be divided by 2, it will become 64, and again this divided by 2, we get 2 3s are 6, 2 2s are 4. 32 again it is divisible by 2, so we'll divide it by 2, and 2 1s are 2, 2 6s are 12, 16 is the quotient. Then again it is divisible by 2, so 2 8s are 16, and it is again divisible by 2, so 2 4s are 8. Again it divide by 2, so 2 2s are 4, and the last 2 is divisible by 2, so 2 1s are 2. In this way we will solve the problem by the prime factorization method, and this is the prime factorization method. Now we will write by the prime factorization. We get 4096 is 2 into 2 into 2 into 2 into 2 into 2 multiply 2 by multiply 2 by multiply 2 multiply by 2 multiply by 2 into 2. Then we will make the pair of digits. Here 2 and 2 makes one pair, again 2 and 2 one pair, 2 and 2 makes one pair, 2 into 2 again makes one pair. In this way we will make the pair of 2 digits. So therefore we can write, for finding the square root problem, we have to write the square root of 4096, that is equal to, from this one pair of 2, when it comes under a square root sign, so one pair 1 2 will be outside of the square root sign. So how many 2's are here? Pair 1 2 3 4 5 6. So 6 pairs of 2 is here, so 6 times 2 we have to write here for square root of 4096. So it will become 2 2's are 4, 2's are 8, 2's are 16, 16 2's are 32, 32 2's are 64. So we can say square root of 4096 is 64. Now let's talk about the next question number 5. For each of the following numbers, find the smallest whole number by which it should be multiplied so as to get a perfect square number. Also find the square root of the square number so obtained. So first question is given 252. So we'll do the prime factorization for 252. So it is divisible by 2. So 2 1s are 2, 2 2s are 4, and 2 6s are 12. Again 126 divisible by 2, 2 6s are 12, and 2 3s are 6. Again this 63 is not divisible by 2. Now this is the 63 is an odd number, so it should be divisible by odd number, not an even number. So 63, next prime number after 2 is 3, so we'll divide it by 3. So 3 2s are 6, and 3 ones are 3. This 21 is the multiple of 3, so again we divide it by 3. 3 sevens are 21, and the next prime number after 3 is 5. So 7 is not divisible by 5, so next prime number is 7, so we'll divide it by 7. So 7 ones are 7. So this is the prime factorization of 252. Then we will write, by prime factorization we have 252 is 2 multiply 2 multiply 3 multiply 3 multiply 7. Here in this prime factorization we get that 2 and 3 are the numbers which is in the pair, but 7, this prime 7 is not in a pair, so meaning is it is not a perfect square as this 7 is not in a pair. So we have to make this 252 as a perfect square number. We need one more 7 to make it a perfect square. So let it is multiplied by 7. So 252 multiplied by 7, that is equal to 2 into 2 into 3 into 3 into 7, this multiplied by 7. Now we get all these numbers are, all these prime numbers are in the pair. So when we write square root of 1764, that is equal to square root of 2 into 2 into 3 into 3 into 7 into 7. So from this pair 2 will come out of this square root side. Again this 3 into 3, from this pair 1 3 will come out, and from this 7 into 7 1 7 will be come out from this square root sign. So inside of square root sign there is only 1, and square root 1 is 1. So we get square root of 1764 is 2 into 3 into 7. So product of 3 2s are 6, 6 7s are 42. So we can say the smallest number is 7, which multiply to get a perfect square number 1764, and the square root of this 1764 is 42. Now in the same way, next problem we have to solve, where we will divide by the smallest number to get a perfect square number. So here it is. For each of the following numbers, find the smallest whole number by which it should be divided so as to get a perfect square, and also find the square root of the square number so obtained. So it is 396. So let find out the prime factorization of 396. So 396, it is divisible by prime 2, so it is divided by 2, then we get quotient is 198. Then 198 again divisible by 2, so again divided it by 2, so we get 99. Then this 99 is divisible by 3, so 3 3s are 9, 3 3s are 9, so we get 33. Again this 33 is divisible by 3, so we get 3 ones are 3, 3 ones are 3, 11, and this 11 is divisible by 11 itself. So we get, this is the prime factorization of 396. So we get in the prime factorization of 396, it is equal to 2 into 2 into 3 into 3 into 11. Now we observe in this prime factorization 11 is not in a pair, that is it is 396, it is not a perfect square number. Now when we want to make this 396 as a perfect square number, we have to remove this 11. So that meaning we have to divide this number by 11. So 396 divided by 11, that is equal to 2 into 2 into 3 into 3 into 11 upon 11. So this 11 and this 11 will cancel out from this prime factorization method, prime factorization numbers, and 396 divided by 11 becomes 36, as 11 3s are 33, 9 minus 3 is 6, and again 66, that is 11 6 is 66. So in the right hand side we get 2 into 2 into 3 into 3. So by making the pair of digits 2 into 2, one pair of digit 3 into 3, this is again one pair of the digit 3. So we can write square root of 36, that is equal to square root of 2 into 2 into 3 into 3. From this, one pair of 2 will come out from this square root sign. Again from this pair, 3 will come out from the pair. So we get 2 into 3 is equal to square root 36, or we can say square root of 36 is equal to 6. So the smallest number is 11, which is divided by 396 to get a perfect square number 36, and the square root of 36 is 6.